This problem was an admissions test for University of Oxford. In this video, I will show you how to solve it. So the problem is an irregular hexagon with all sides of equal length is placed inside a square of side length 1, as shown below, not to scale. What is the length of one of the hexagon sides? And as you can see, this is a multiple choice question, so we have to find the correct answers. So this is the picture of our problem, which is not to scale. And the question is, what is the length of hexagon sides? As you can see, hexagon is in red. We have 5 different answers and our job is to pick the right one. Let's take a look at our square. Let's say that the length of one of the hexagon sides is x. So we have x in these positions, because all the sides of this hexagon are of equal length. The hexagon is irregular, so not all the angles have to be of the same size. And now we just have to find the length of x. We know that the square has a side length of 1. The question now is where to start. When dealing with problems like this one, I always like to start with boundary conditions. We see that x is the length of a side of this hexagon, and that means that x has to be larger than 0. We can also observe that hexagon is inside the square, and that means that side of the hexagon has to be shorter than the side of the square on which it is sitting on. That means that x has to be smaller than 1. We finally get the boundary condition to be 0 is smaller than x and that is smaller than 1. Let's now take a look at this triangle. We can immediately observe that this is a right-angled triangle. It has a hypotenuse of the length x, and that x is exactly what we need to find. At this point, we can use the Pythagoras theorem to find this length x. We need the length of both catheti of this right-angled triangle. We know that the side of the square has the length of 1, and we know that the length of the side of a hexagon, which is lying on top of this side of the square, is x. That means that the remaining part has the length of 1 minus x, and that is this part right here, 1 minus x. Therefore, the catheta has the length of 1 minus x. The same happens for the other catheta of this triangle. Now we know everything that we need for Pythagorean theorem. The Pythagorean theorem claims that the square of hypotenuse is equal to the sum of the squares of both catheti. Mathematically speaking, in our case, that means that 1 minus x squared plus 1 minus x squared is equal to x squared. That means that 2 multiplied by 1 minus x squared is equal to x squared. The question is, what is 1 minus x squared? That is 1 minus x multiplied by 1 minus x. To solve this, we are going to multiply each of the members of the first bracket with every member of the second bracket. So 1 multiplied by 1 is 1. 1 multiplied by negative x is negative x. Negative x multiplied by 1 is negative x, and negative x multiplied by negative x is positive x squared. This is equal to 1 minus 2x plus x squared. Now we are going to return with this information into a previous step. We have now 2 multiplied by 1 minus 2x plus x squared to be equal to x squared. That means that 2 minus 4x plus 2x squared is equal to x squared. And what we can now do is get rid of this x squared on the right side of the equation. We are going to do that by subtracting x squared from both sides of this equation. So we have 2 minus 4x plus 2x squared minus x squared to be equal to x squared minus x squared. Our equation then becomes x squared minus 4x plus 2 equal to 0. We now have to solve this quadratic equation. Remember that in general case when ax squared plus bx plus c is equal to 0, then solutions of the quadratic equation are given by the formula negative b plus or minus the square root of b squared minus 4ac, everything divided by 2a. In our case, a is going to be equal to 1, b is going to be equal to negative 4, and c is 2. So when we return this, we have that x1 or 2 is equal to 4 plus or minus the square root of 16 minus 4 multiplied by 2 divided by 2. This is equal to 4 plus or minus 16 minus 8 divided by 2, and that is equal to 4 plus or minus the square root of 8 divided by 2. We can write this as 4 plus or minus the square root. 8 is going to be written as a product 2 multiplied by 4 and then divided by 2. We can now separate these numbers under the square root as square root of 2 multiplied by the square root of 4, and then we get that this is equal to 4 plus or minus 2, which is a square root of 4 multiplied by the square root of 2 divided by 2. And when we simplify this, we get 2 plus or minus the square root of 2. So we now have that one solution of this equation is 2 plus the square root of 2, and the other solution of the equation is 2 minus the square root of 2. We have two solutions for the problem. Let's now see if both of our solutions are valid. We know that boundary condition from our problem is 0 has to be smaller than x, and that has to be smaller than 1. For this solution x1, which is equal to 2 plus the square root of 2, we know that this is strictly larger than 2 and that is strictly larger than 1. So x1 doesn't satisfy the boundary condition. That means that x1 can't be a solution to our problem. If you look carefully, there is x1, which is equal to 2 plus square root of 2, offered as one option, option E, in this problem. So if you select that one without checking the boundary condition, even though it is offered by the makers of this test, you will be in the wrong, as that can't be a solution. That option only exists to bait you into making a mistake. Now, what happens with the solution x2 is equal to 2 minus the square root of 2? We know that 1 is smaller than 2, and that means that square root of 1 is smaller than the square root of 2, which means that 1 is smaller than the square root of 2. Well, that means that negative 1 is larger than the negative square root of 2. What we can do now is add 2 on both sides. We get that 2 minus 1 is larger than 2 minus the square root of 2, and that means that 1 is larger than 2 minus the square root of 2. We know that square root of 2 is strictly smaller than 2, and that means that 0, which is equal to the square root of 2 minus the square root of 2, is smaller than 2 minus the square root of 2. What we have now is that 0 is smaller than 2 minus the square root of 2, which is smaller than 1. And this satisfies our boundary condition. That means that 2 minus the square root of 2 is a solution to our problem. Let's just select that option in B. And we are done with this problem. I hope that you have enjoyed this video. If that is the case, I would recommend that you watch this one next. Please like, share and subscribe as that helps the channel a lot. Don't forget to leave the comment as I love reading those.